Hey everyone, today we're gonna do the Canadian Computer Competition Year 2018 Junior Problems, Problem J4, SunFlowers. This one is also the second problem in senior problems, problem S2. And now let's read the problem. So Barbara plants n different sunflowers, each with a unique height ordered from smallest to largest. So these sunflowers are ordered and records their heights for n consecutive days. So this is a n by n matrix. Each day, all of her flowers grew taller than they were the day before, and she records each of these measurements in a table with one row for each plant, and with the first row recording the shortest sunflower's growth and the last row recording the tallest sunflower's growth. The left column is the first measurement for each sunflower, and the rightmost column is the last measurement for each sunflower. In this n by n matrix, each row is for a plant, and each column is for measurement in a day. If a sunflower was smaller than another when initially planted, it remained smaller for every measurement. So you can see here, these sunflowers are pretty regulated. If it's the smallest from the beginning, then it's still the smallest at the end, no matter how much it grows. Okay, so now we have n by n matrix, and row-wise or column-wise, the numbers are from the smallest to largest. So they are ordered very well. And unfortunately, her children may have altered her measurements by rotating her table by a multiple of 90 degrees. So here, even the rotation is also very regulated. So each rotation is based on 90 degrees. And your job is to help Barbara determine her original data. So when the table is rotated, we don't know how many times of 90 degrees. We need to reset the table and get the original numbers. Now input specification. So the first line of the input contains the number n. So I remember we have a n by n matrix. So we have n here. This n is between 2 and 100. And the next n lines each contain n positive integers, each of which can be very big. So the biggest number is 1 plus 9 zeros, so it's 10 digit, which can still be held in a 32-bit integer. It's guaranteed that the input grid represents a rotated version of Barbara's grid. So we have n lines of numbers, and each line has n numbers, but this is not the original data. This is after the rotation. It may not be ordered, and we should not expect order number from the input. The output Barbara's original date. So this is the original n by n matrix, and in the output, all the numbers, row-wise or column-wise, should be ordered well. Now we have the samples. So the first sample is a 2 by 2 table. So the first line is 2, and then we got 1, 3, and then 2, 9. If you check this table, you can see that row-wise or column-wise, the number ordered pretty well. So this is the original data, or this is same as the original data. So the output is same as the input. So the data has been rotated a multiple of 360 degrees. So it's still same as the original arrangement. And now sample input 2. And here we have an example of n as 3. And we have, now you can see in this input, row-wise or column-wise. Column-wise, the numbers are still ordered well, but row-wise they are not. And in this case, we cannot consider the column-wise numbers are good. So we have to find the original table. So you can see in the output, the original data looks like this. So even column-wise is not same as in the input. This matrix is rotated for 90 degrees, or 90 degrees plus multiple 360 degrees. It doesn't matter. And now let's say sample input 3, same n as 3. It looks like this is the same numbers as in input 2, but rotated more. So it says 90 degrees to the left, counterclockwise. But if you think it as clockwise, it's like 270 degrees. And this is the output, same as in sample 2. Now let's analyze the problem. So we have 3 samples, and the first one is 2 by 2, as it's ordered very well. So we're not going to use this one in the analysis because it does not change from the input to the output. We will analyze the other 2 tables, and we use A for this table and we use B for this table in sample 3. So as we can see from here, this is the input, this is the output. So the first step, we need to find the smallest number in all the numbers in the table. In this case, it's 1. And then in the output, we should print this number first. And same for table B. So in the input, we need to find the smallest number and then print it out first. And then once we have the smallest number, and then we can go column-wise on the smallest number to get the first row. This is for table A. And for table B, when we find the smallest number, we need to go row-wise to find the first row in the output. So depends on where the smallest number is, we're going in different directions. And now, after we got the first row, and then we need to go column-wise. And column-wise for table A is going to the left. And for table B is going upward. So you can say in the output, by column, the numbers goes in a different direction from the input, and also depends on the location of the smallest number. So first, we need to find the smallest number in the table, and then based on the location of the smallest number, we go different directions to get the row, and another direction to get each row. So now we do a generic table. Let's assume the original data is like this. So originally in the table, the smallest number is in the top left. And then row-wise, we go from left to right, and column-wise, we go from top to bottom. And now, what if the table is rotated for 90 degrees? The smallest number is on the top right, and then for the first row, we need to go downward, and then for other rows, we need to go to the left side to get each row. And then let's say if the table is rotated 180 degrees, then the smallest number is on bottom right. And then for the first row of the numbers, we need to go from the location of the smallest number to the left. Then for each row, we need to go upward. And then if it's rotated again, now we have this table rotated 360 degrees, And now the smallest number is on the bottom left. And then for the first row, we need to go upward. And then for each row following, we need to go to the right side. And then if this table is rotated another 90 degrees, it'll be same as the original table. So you don't have to change anything. But still, you need to find the smallest number, which is at the top left. And then for the first row, you go to the right side. And then for other rows following, you need to go to the bottom. Here is the directions of the numbers based on the location of the smallest number. These 4 tables include all the scenarios based on the condition that the table is rotated based on a multiple of 90 degrees. No matter which scenario this is, we need to find the smallest number first, and then based on the location of the first number, we decide which way to go. Now let's see how we do it in the code.